Students, you are welcome to a new topic in general mathematics, change of subjects. So, when do we do change of subjects? Change of subjects and substituting into formulae, right? And substituting into formulae. It means we can substitute certain things to this formulae. Good. So, before we start, reminders, please subscribe if you have not done that. And always visit our playlist anytime you are visiting our channel, right? Okay, thank you. Now let's go. Find the value of everything you see here when A is 2, B is minus 1. Get it just straight away, right? So let's go. You just have to substitute, right? When A is 2, whenever you see A, you put what? And you put the power there. This is plus 2. Whenever you see A, you put what? 2. Whenever you see B, you put negative 1 or square. That is a plus. It should be here. Whenever you see B again, negative 1 or Q. Right. This will give me 8. 2 to 4. Negative 1 square will give you positive 1, okay? When you square a negative, you get positive. Take note, please. When you square this, you get negative 4. That is wrong on a calculator. So please put it in brackets on your calculator to get the actual answer, okay? Good. So this is sum for minus 1. How did you know? Minus 1 times minus 1, that's positive 1, right? Times another minus 1 will give you negative 1. If not, you can do your checks on the calculator. So this will give me 11. So welcome to change of subjects and substituting into formulae. 1993, question 38. That's a sample question. If 2 over A equals 1 over B minus 1 over D, find D. Find an expression for D in terms of A and B. This means you have to make D the subject, right? And what you should be seeing on the other side should just be A and B, that's all. So after making D the subject, when you see something like A with C, that's wrong. So when you make D the subject, you should be seeing just A and not B. That is it. So let's look at this question. 2 over A equals 1 over B, 1 over D. We have various approaches here, right? I can decide to multiply through by the LCM, that is ABD. So ABD times this. ABD times 1 over D. 1 over D by what? ABD. So this and this goes off. ABD off, AD off. Now this and this together, do you see? I get 2BD equals AB minus AB. I have been asked to make D the subject. I have D on the left, I have D on the right. Now, which of the D's am I making the subject? Okay, I feel like making this the subject. Now, what about this? There's a little confusion, right? Mathematical confusion. So, what I have to do is that, why don't I put them together and ask them, who do you want to represent you? Are you okay? Now, push us to the concept of what we call factorization. Because I'm qualified to make the subject. I'm also qualified to make the subject. So let's put them together and ask them what they want to do. Okay, let's put them together. Good. I want to solve this way. I'll solve two forms for you, right? I want to show you something. I carry this one here, agree? And there's negative here. It goes just because, are you okay? I'm trying to avoid a negative. 2B. Now, I can factor D out. So we have AB equals D out, A minus 2B. Did you see? Now, we have AB over what? A minus 2B. We have D, A minus 2B, all over A minus 2B. Good. I have to divide 2 by that so that the D can stand alone. I have been asked to make this, make D the subject, or find an expression for D in terms of what? A and B, and I've done that. Please, what's something there for me, okay? What's something? That is correct, right? If we're having that in the objectives, this is not the answer to the objective. What's something? That's correct. Do you believe this correct? Okay. From here, to bring this here. I hope you know it's possible, right? Are you aware? Good. So I make D the surface. I get 2b minus a or negative a. Agree? Good. Now I have to divide through by that just to set the D free. Now my D is free. Now look at the two answers we have in here. Now before I ask my question, am I right? Did you see any forgery in my weapon? I'm also right here, right? Look at the two answers. So which is which? Which is correct here? Here, the 2b was negative. Here, the 2b is positive. The a is positive here, but the a is negative here. AB is positive here. Wow, what is going on? It happens, right? Students, if you want to solve this way, so does it mean coming this way is not good? I have to go the other way? What do you think? I hope you are getting me, right? Yes. Okay. This kind of working you see here is a complex form of working. It's correct. But it's just meant for those who can see. So did you see my trick here? Anytime you are working and you see something negative right there over there, you can try to avoid it. So you see, I carry the whole of this over here. So I avoided any free negative sign. So you see there's no negative sign anywhere, right? And when I have the same sign, I was free. Now those who have these answers are straightforward answers. It's correct. I'm also correct here. And there is something here. And when you get here, see, if you're not so good in maths, remember, try and avoid negatives. Now watch here. You see this minus here. That is its position. Now it belongs to this. Now this minus here will attack expressions with operations. Now there's no operation here, right? So the minus will attack this way. Look at it. See, we are on track. The minus 2b, you can see it here. A is positive. This A is positive. This minus belongs to this. Okay? So A is positive here. That's it, right? Minus 2b. So how many people can even comprehend or understand this? So please take note to make your work easy. Avoid free negatives. You know what we call free negative? Watch here. So these are free negative standards, right? Avoid them. You can avoid them by taking them over to the other side, okay? So they become positive. If not, you don't see. Now watch. What if my expression was like this? What will I do? The minus will still attack the top, not the line. So the minus runs through the expression with the operation. Are you okay? Good. So although this minus belongs to this AB, it is now in unison with the operation. It's for everything now, right? So it runs through the operation. Everybody knows this. So it's very good, right? I think that's the effects. So we have to get to solve and get that. Good. Now let's look at this question. V equals pi a squared or into brackets r minus h over 5. Express r in terms of v, h, and I. I have to make this r the same. Look at where r is. So one may say, let's multiply through by 5. 5 pi a squared like this. Fine, you can still release it. But sometimes you can look at the question critically and see how best you can just attack it very simple. Right? V so I can multiply through by 5. So now the very lengthy. Look at what I want to do here. So what I can do here is this. I can divide through by pi h squared. Please, why am I doing this? Or in fact, what I'm doing is just to make r stand alone. That's the trick. So whatever you do to this equation to make r stand alone is what we are looking for. Okay. So I have v over pi h squared. Pi h squared r minus h over 5 all over pi h squared. R minus H over 5. V over pi A squared. Look at it. Good. So you look at it, it's just like you having 2x and 4. How can you get an x and the loop? You divide both sides by 2, right? When they give you the question, use all the methods that you can, right? To make it simple. Now there's what I will do. I'll just carry this one here. Wow. Okay. What matters is that R is a loop. That's what matters. Once R is a loop, I'm done. I don't care about what's going on here. They asked me to make R something, right? That's what matters. Why do I care about whether it is V or pi? No, that's not my business. Are you okay? So that is it. So the approaches are many. Look for the easy way out.